Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, this is chapter 4.4, Probability, the Basis of Insurance. Objectives in this chapter section are, we're going to explain how to interpret two-way tables, compute conditional probabilities based on two-way tables, determine if two events are independent, interpret Venn diagrams, and create them as well. Okay, so there are some vocabulary words here, so let's hit that next. Oh, actuary. Okay, actuarial science is what it's called. An actuary is someone who takes this specific test to become an actuary, and then if they pass this test, then they generally will get hired at like an insurance company or some large corporation. And their job as to be a statistician who predicts how many customers will submit claims based on criteria such as age, sex, marital status, driving record, and residence. There are several steps to become an actuary. There's one test, there's level one tests, and there's a second, and then a third, and then a fourth. And the more tests you pass, the more money you make because you're learning the larger areas of actuarial science. Okay, so probability is a relative possibility that an event will occur. What is the probability of flipping a heads with a coin? Okay, and there's a relative possibility that heads will occur if I flip it, so that's a probability. An event is the outcome. So if I flip that coin and it comes up tails, the tails is the outcome of that experiment. A two-way table is a two-way table is a way to display frequencies or relative frequencies for two categorical variables. One category is represented by rows and a second category is represented by columns. We'll take a look at those in this chapter. Conditional probability, that's the probability of an event A given that another event B has already occurred. And we'll get into that in some examples here to this lesson. And then independent events are two events that are independent if the probability of one occurring is unaffected by the occurrence of the other event. A Venn diagram is two events are independent if the probability of one occurring in, oh, that's not right. I gotta fix that. Okay, that's better. A diagram representing mathematical or logical sets pictorially as circles or closed curves with an enclosing rectangle, the universal set. Common elements of the sets being represented by intersections of the circles. So we'll take a look at those in this chapter. Okay, example 1 says a pail contains 7 red. So let's just underline these. 7 red, 6 green, 3 orange, and 4 black marbles. 1 marble is to be drawn at random. What is the probability that the marble is red? So I'm going to say the probability, outcome R, is going to equal number of red marbles divided by total marbles. Okay, so in doing that, the number of red marbles is 7 divided by 7 plus 6 plus 3 plus 4. 7 and 6 is 13, and 3 is 16, and 4 is 20. So there's 20 marbles in this pail. Okay. So 7 over 20 is equivalent to 3.5 over 10, which is 35%. So the probability of drawing a red marble out of that group of marbles in that pail is 35%. Okay, check your understanding. The driver's education class at Monroe High School has 23 girls and 20 boys. So 23 plus 20 equals 43. That's our total. If one person is selected at random to represent the school in a driver safety exposition, what is the probability that the person selected will be a girl? Girls is right here, 23. So the probability of a girl being selected equals number of girls. Okay, I'm not going to write this every time. Number of girls divided by the total. Okay, so if we get our calculator out and we take 23 divided by 43, that is approximately 53% chance that a girl is chosen. Okay, the extend your understanding is probability without replacement is what it's called. And it says Logan picks a black marble from the pail in example 1. Okay, so our total was 20 and there were 4 black marbles. So if you take one away of black, now we have 3 black. Okay, we have 3 orange. Because orange was not chosen. So there were 4 blacks, but Brett randomly selected a marble, or it says Logan selected a marble that was black. So that reduces the number of blacks by 1. Oranges are still 3. Green is 6. And 7 red ones are still there. Okay. That's like a Greer. Okay. So 3 plus 3 is 6, plus 6 is 12, plus 7. That total is now 19. So without replacement means that black marble is now sitting off to the side here. Whoops. So here's this black marble sitting over here, and we still have a pail with all these in it. So the total is now 19. And now it says what's probability that Brett picks a green marble. So the probability of green is going to equal the number of greens over the total. Okay, so it's 6 out of 19. If you want to put that into a fraction or into a percentage, 6 divided by 19 is approximately 32%. Okay, but it doesn't ask that. So usually what you do is just leave it in fraction form. Same with up here. So those are the 2 understandings. All right, example 2 says a factory. Oh, by the way, this is a two-way table, as it states right here. That was a definition word from the first page. All right, so it says a factory is planning to rearrange the parking spaces in its parking lot to better serve their employees. The employees work in 3 different shifts and drive 5 different types of vehicles. So there's a morning shift, a day shift, a night shift, and 2-door sedan, 4-door sedan, SUV, pickup truck, and motorcycles are the categories that they have for parking, as shown in the two-way table below. An employee is selected at random, so it's a random selection. What is the probability that an employee drives an SUV? So the first thing you do is start out with probability of SUV equals, and you want the total SUV. So SUVs is this column right here. Okay, let me just do this neater. Let me use this. Okay, here's SUVs, and you want the total. All right, so the total is right here. So all you're going to do is take the probability of SUVs is the total number of SUVs divided by the total number of vehicles. And if I put that in my calculator, 91 divided by 246 is approximately 37%. Okay, if they're looking for an exact, you should leave it 91 over 246. Okay, check your understanding. It says using the table from example 2, find the probability that a randomly selected employee is on the night shift. Okay, so let me erase this. A randomly selected employee is on the night shift. So now I want to change my selection here to the night shift. So there's the values we're going to be looking at here. This isn't cooperating. All right, so let me just do this over. Square, red's fine. And I want this night shift. Okay, close enough. This is the row we're looking at. Okay, night shift. Here they are. Here's the total. 59 work the night shift out of the 246. So it says find the probability that a randomly selected employee is on the night shift. So that'd be the probability of n equals, and the total is 59, divided by the total employees of 246. Putting that into a percent, you take 59 divided by 246, and it is 24% roughly. Okay. 59 out of 246. All right. Extending your understanding, it says using the table from example 2. What is the probability that a randomly selected employee drives a motorcycle and is on the morning shift? Now, this is a little bit different. Okay. The word and means that we have to take both things into consideration. So we're on the morning shift now. So we move this up to morning. So we're looking at these values here. And drives a motorcycle. So we're looking at this. Okay. All right, so all we have to do is take a look at where those two intersect, which is right here. So there are 4 people on the morning shift who ride motorcycles out of the total. So the probability of driving a motorcycle and on the night shift, or morning shift, motorcycle, C, is equal to 4 out of 246, which would be 2 out of 123, reducing to approximately 1.6%. Okay, so this symbol here just means intersect, meaning and. So the probability of morning shift and motorcycle is 4 out of 246, which is approximately 1.6%. Okay, example 3 says the factory from example 2 is thinking of closing part of the parking lot at night since there are fewer night shift workers. What is the probability that an employee drives a motorcycle given that they work the night shift? Okay, this is a conditional probability. When it says given, something's already occurred. Okay, so I'm going to release the table from the book, but I wanted to point out that there is a misprint in the book. Okay, so before we continue, if you have this addition, it says down here the solution. This is an example of conditional probability. Since we are given that the person works the night shift, the denominator will be the total number of people who work the night shift. Well, that's right here. Okay, this is indicated by the yellow cell on the table. Well, they didn't put the yellow cell for the total number of employees, not the total working the night shift, and that is where the misprint occurred. Okay, so let's get rid of that and let's fix this. So we're not going to be looking at the total number of employees. We're looking at the total number of night shift workers. So the probability of someone driving a motorcycle, which is C, the probability of C, whoops, I forgot my given, the probability of C given that they work the night shift, that's how this is written, the probability of C given they're on the night shift. So that means we're going to focus on just the night shift is going to equal the number of motorcycles in the night shift divided by the total number of workers at night. So it's 55 over 59, not 5 over 246, which is what you might put if you didn't read that carefully in the book and you saw this highlight here. So when I simplify this, 5 divided by 59 is approximately 8.5%. Okay, but 5 over 59 is the exact. Now check your understanding says using the two-way table from this example 2, which is this example, this is this two-way table from example 2 as well. Okay, so let's get all this out of the way. Find the probability that a randomly selected employee works the night shift. So we want to know what the probability is that they're working this night shift. Now let me just do this like so. Let's put a rectangle around it. Let's do orange this time. They are working the night shift. okay? Given that they drive an SUV. So we're going to use these two columns. Where do they intersect? At 19. So the probability that randomly selected employee works a night shift, given that they drive an SUV, is probability of n given s. And that equals total number SUVs on a night shift is 19 out of the total number of night shift workers, which is 59. And when I put this into a percent, 19 over 59 is 3.2%. 32%, I'm sorry, approximately 32%. Okay, in reviewing that, I made a mistake. We do want to use these two columns, but I used the wrong total. I do not want to use 59. Okay, that is our given. So total number of night shift workers who drive an SUV out of, we already given that they drive an SUV. The word given that they drive is our denominator. That should be 91. I apologize for that. 19 divided by 91. And that is 21%. Okay, sorry for the mix up there. Okay, example 4 says Justin is doing a statistical analysis to check if sports cars in his town are involved in more accidents than other types of cars. He polls 315 randomly selected parents of students in his high school and gets the results shown in the table below. Does the table support Justin's theory that sports cars get into more accidents? So what we need to do is determine if this is an independent event or an associated event. And what that means is we want to know if the probability of getting into an accident is going to be equal to the probability of getting into an accident given that we have a sports car involved. And if these two are equal, they're independent events. If they're not equal, they're associated. Okay, so we'll find the probability of A first. So the probability of an accident equals, so has had an accident is 150 out of 315. And we're going to convert this into a percent. So 150 divided by 315 is approximately 48%. Now, what I want to know is if this is going to come out to be the same or different. If they're equal, then they're independent events. So now I'm going to take the probability of A, given it's a sports car, probability of an accident given they're sports cars. So now let me erase this and I'll do this one in red. So here's our sports cars. Probability of an accident given they're a sports car. All right, so had an accident, already given that they're sports car. Remember, the given is the denominator. So the total sports cars is 105. So I wrote 150, okay? 105 is my denominator. 50 had an accident is my numerator. Check to see what 50 divided by 105 is. And that comes out to be 47. And as you can see, they're exactly the same. So that's also approximately 48%. So since the probability of A equals the probability of A given sports car, since they're equal, these are independent events. And since they're independent events, the table does not support Justin's theory that sports cars get into more accidents. So the answer is no. Now it says using the table from example 4, explain whether or not N and SD are independent events. Okay, so we want to take the probability of N. So the probability of N is never had an accident. So the probability of n is never had an accident. And that totals 165. So we're going to take that 165 out of the total 315. And when I put that into a percentage, 165 divided by 315 is approximately 52%. Okay, now we're going to do the probability of SD, that's sedan. The probability that a vehicle is a sedan is the total number of sedans, 114, I'm sorry, not 140, that have never had an accident. So explain whether or not N and SD are independent events. So now I want to find the probability of, we found the probability of N. Now I want to find the probability of N given that it's a sedan. So the probability of N given it is a sedan, we're going to use these values here. N is here, total is 45. Never had an accident in the sedan column is 45. Divided by total number of sedans, which is 114. And that's going to be approximately 45 divided by 114. And that comes out to be approximately 39%. Okay. So it says, explain whether or not these are independent. So since they're not equal, they are not independent, not independent. And when something is not independent, then it's associated. Okay, so they are not independent, they are associated. Okay, John V is judging a classic car show. She is also preparing a report on the cars in the show. There were 135 cars at the show. 70 of the cars had manual transmission. Okay, so let's stop right there. 57 plus 13 is 70. Manual is in this circle. So manual transmissions are cars that had manual transmissions that did not have air conditioning, and manual transmissions that did have air conditioning are included because they're both manual transmissions. Okay. So those would be those two. 43 had air conditioning. 30 have air conditioning that were not manual transmission, and 13 had air conditioning and manual transmission, totaling that 43. That's how you read these Venn diagrams. Okay, and then finally, 13 had both manual and air conditioning. So that is our union, our intersection, I'm sorry. That is our intersection. And that is just this area right here. So if they ask which cars had manual and air conditioning, it'd be 13. Okay. And 35 had neither. So when they don't have manual or air conditioning, then the value is down there. That's the neither. All right. So that's kind of how Venn diagrams work. So if I add these up, 57 and 13 is 60, plus 30 is 90, plus 35 is 125. Is that right? 57 and 13 is 70, plus 30 is 100, plus 35 is 135. So these numbers should all add up to our total in the car show, and it does. So now a car will be selected at random to appear on the cover of the report. What is the probability that the car will have air conditioning, but not a manual transmission? Okay, so it has air conditioning. It's going to be in this circle A. Okay, but not manual transmission, meaning automatic. We're not going to count this 13. So the answer is, excuse me, 30. Okay. Sorry about that. I'm fighting a really bad cold, but you know what they say, the show must go on. So the probability of A equals the probability of air conditioning equals number of cars with air conditioning and no transmission, no manual transmission, which was 30. divided by the total, which is 135. So the probability is 30 out of 135. Okay, so 30 divided by 135 is approximately 22%. All right. Okay, check your understanding. The following Venn diagram described cars on the lot at Michelli's used car showroom. The letter B. Hey, I changed this. What's going on? The letter B is used if the car exterior is black, and the letter T is used if the interior is tan. So that's what the B and the T stand for. Exterior black, interior tan. What is the probability that a randomly selected car from the lot is not black? So if it is not black, then it's got to be over here. Okay. And in all actuality, it's outside. Okay. So the only black exterior cars is this circle right here. In other words, not black means the opposite, everything that's not in this circle. So it's 39 and 112. So the probability of something not being black, okay, equals the probability of it having a tan interior and not black, which is 39, plus the probability of it not having a tan interior or a black neither, 112, over the total, which was 135. So 9 and 2 is 11, 3 and 1 is 4, plus 1 is 5, and 3 and 1 is 4. Oops, what am I doing? 3 and what am I doing? Just 1. 151. Okay, 151 out of 135. Okay, so the probability of a random selected car is 151 out of 135. Let's see what that is as a percentage. The total was 135, right? Yeah, 135 cars at the show. Oh, I'm sorry. I'm thinking of that show. This isn't the show. This is a totally different set. So what you have to do is you take that 112 plus 39 plus 8 plus 17, and that is our total in this problem. 9 and 2 is 11, and 8 is 19, and 7 is 26. Carry the 2, 2, 3, 6, 7, 7, 176. So the probability of it not being black is 151 out of 176. I am really struggling here. This cold is killing me. All right, can't think straight, can't speak. 151 over 176. So if I put that in the calculator, 151 divided by 176 is approximately 86% are not black. Okay, moving along, extend your understanding. Using the Venn diagram from the previous, so let me erase all of this stuff I put in here. I don't need this anymore. We got our total. And this is not 135, it was 176. I didn't fix that. Using the Venn diagram from the previous check your understanding problem, how many cars have a black exterior or a tan interior? So that word or means it can be a black exterior or a tan exterior. All right, but be careful. If I do it this way, do not add this 8 twice. Either count it as a black exterior or count it as a tan interior. So if I were to do this problem, I would not include the blue going in there or the green, either way, and I'd do this. So it's going to be 17. So the probability of how many cars have a black exterior or that's this, no, that's and, or that's union, or looks like this, by the way, black or tan, but is 17 plus 8 plus 39 over 176. So 9 and 8 is 17, and 7 is 24. Carry the 2, 5, 1 is 6 over 176. So it doesn't say what's the probability, never mind, but that would be the probability. It just said how many cars have that exterior. Okay, so I should read my problem. I did go back and read it more clearly. How many cars have a black exterior or a tan interior? And it's 17 plus 8 plus 39, which is 64 cars. All right, example 6, using the Venn diagram from the previous check your understanding problem, which I brought in right here. What is the conditional probability that, so it's conditional, we already know that it's the probability of something given something. That word conditional tells us that. Randomly selected car is black, given that it has a tan interior. So the probability of black given its tan is. So remember, the denominator is going to be your given, and tan is this circle right here. So the probability of tan is 39 plus 8. Probability that it's black given it's tan, I'm not going to count these because that's not tan. I only need this number right here. Probability it's black in the tan circle is 8. So that's going to simplify to 8 over 39 plus 8, which is 47. Okay. So the probability that a randomly selected black car is given that is a tan interior is 8 out of 47, which is approximately 8 divide 47 is 17%, roughly. Okay. All right. Check your understanding. Using the Venn diagram from example 5. So this is the example 5 Venn diagram. What is the probability a randomly selected car has air conditioning given that, okay, probability, air conditioning, given that it has a manual, equals, well, the probability that it has a manual is our denominator, and there are 70 cars that have manual transmissions. Okay, so what is the probability a randomly selected car has AC given that it's manual? And the answer to that is these are the only cars that have AC and manual. It's 13 over 70. And that is approximately 13 divide 70 is approximately 19%. Okay, example 7, we're now going to shift our direction from Venn diagrams to normal bell-shaped curve and standard deviations. So in example 7, it says the amount of money Durham Insurance Company has paid out in comprehensive claims is normally distributed. So as soon as you see this word right here, then you can think of a normal distribution bell-shaped curve. And it says the mean is $887. Mean is represented by the Greek letter mu. Okay, so that's 887. So I'll just put that down there right now. So this is $887 right in the middle there. That's our mean. Standard deviation of $301. Okay, so there's our standard deviation, and that is represented as the lowercase sigma in the Greek alphabet. Okay, so what you do is you take this $887 and add 301 to it, and that will give me 8,811.88. That is this value right here. So this is $1,188. That's one standard deviation above. And if I do it again, it's 301 more, 9,841. Now we're at 1,489 for 2 standard deviations out. And then one more time, I'll go up 3. 9 and 1 is 10. 8, 9, 7, 1. So this is 1,790. Now going the other way, one standard deviation negative would be 887 minus 301, which would give me 6, 8, 5. So this is 586. I'll change colors for this side. 586. Not very neat. Let me try that again. Okay. 586. Subtract 301 from that, and we're going to get 582, 285. And then we're getting into negative, so I'm not going to go any further there. Okay, so we should have probably gone out 2 standard deviations. Anyhow, that's the setup of a normal distribution curve given this information. So let's continue. Now it says Durham is doing a survey of their customers. If a person who made a comprehensive claim with Durham is randomly selected, what's the probability that their claim will be less than $1,200? So I'm going to just draw a solid line at 1,200. And 1,188 is here, 1,489 is here. So this is only $12 off. So my line is going to be approximately there. Okay, and what I want to know is I'm going to shade this side here. So let me see if I can do that. Okay, so I just copied this from the book. I don't agree with it. And the reason is this is like a half a standard deviation, which would be like $150.50 more than our 1188. And we're only $12. So the actual line should be like here. I don't know why the book did that, but that's a half a standard deviation. So just think of the red over shaded. That's what we're trying to find. What is the probability that their claim was less than $1,200? This is going to require z-scores. So you say z equals, and z equals our value minus our average or our mean, mu, divided by the standard deviation. So that's the formula, z equals x minus mu over sigma. Okay, and so z is going to equal our x value of $1,200 minus our average, which is 887, divided by our standard deviation, which is 300 million. So when I simplify this, I get 3, 1, 3 over 3. Is that right? 1,200 minus 887. No, that's not right. 1,200 minus 887. 313 divided by 301. Oh, it is right. Okay. 313 divided by 301. So I'm going to put that in my calculator. Divided by 301, our standard deviation. And we get 1.03986. 1.039 or 1.04. That would round to 1.04. Okay, that's an approximation. Okay, so now we have to look that up in our Z table. So as the book states, if you turn to page 718, there is an appendix A with a Z table. Okay, so here's my Z equals 1.04. I'm going to maximize this, my appendix A, remember 1.04. So I'm going to go up here, and Z scores can go from negative 3.8 all the way down. And on the first page, it goes to negative 0.00 or just below 0 here. And then continuing on, now notice it's 0.0 and then hundredths are over here. We want 1.0. So here's 1.0. 1.00, 1.01, 1.02, 1.03, and 1.04 is 0.8508. So that is 0.8508 or approximately 85%. Okay, so that just means what's the probability of a claim being less than $1,200? The probability is 85%. That is less than $1,200. 85% of the data is below $1,200. Okay, hopefully that makes sense to you. And let's continue with the check your understanding. Find the probability that a randomly selected person made a comprehensive claim between 1,200 and 1,400. Okay, so here's what we're going to have to do here. Here's the 1,200 line. Let me draw another line where $1,200 more, which would be over here somewhere. So if I want to know this region here, I want to take the higher 1,400 z-score and subtract the lower to get rid of this over here to get what's in between. So that's what we have to do. We have to take the z of each of these. So I'm going to say the z sub 1,400 and subtract minus the z sub 1,200 will equal what we're looking for. Okay, and so I have to do two z-scores. So write the formula every time until you memorize it. It's x minus mu divided by the standard deviation. Substitute in the givens. Our x for this is 1,400. Let's do that first. Our x is 1,400 minus our average 887 divided by our standard deviation. Okay. All right, so now I'm going to do z of 1,200. And that's going to be 1,200 minus our mean divided by our standard deviation. So when I get these two, I'm going to get 1,200 minus 887. Which is 313. Oh, we already did that one. Hello. Over 301, which is approximately 1.04. I'm going to do that again. The other one is 1,400 minus 887 divided by 301, which is 53 over 301, which is approximately 17.6%. Okay, what am I doing here? 0.176. What am I doing? I'm not putting into percentages. 0.176, which would round this to 0.18. So we already did this one. We don't need to do it again. Okay, so we got the ZDV 1 point. So this is 85%, 0.8508. So this came out to be 0.8508. And this one is going to come out to be whatever 1.8 is in our appendix A. So if I go back to here, I'm looking for 1.8. So here's 1.0. Was it 1.8? Look at my calculator again. 0.1760, which rounds to 0.18. 0.18. 0.18 is right here. So it's 57.5714. So this is 0.5714. So you subtract the Z 1,400 from Z 1,200. I've got this backwards. Okay, I don't know what I pressed in my calculator, but I'm looking at this 53 over 30. I'm like, where did that come from? Must be the NyQuil or DayQuil. All right, so anyhow, let me be more careful here. 140 minus 87. Wow, the buttons didn't. 1400 minus 887. Enter. Divided by 301 is 1.70. I look up 1.70 in my appendix A. 1.70. 1.70 is 0.9554. Okay, so this is going to be 0.9554. So the answer to this question is Z1400. I was right. Over here, I was wrong in my pushing my buttons. Wasn't paying attention. So the Z1400 score is 0.9554 minus 0.8508. So I'm going to take this number, 0.9554 minus 0.8508. Enter. And I got approximately 10.46%, or roughly 10%. Okay, so that's how much would be in between those two. Okay, example 8. Boy, they really threw in a lot in this chapter. Now we went from Venn diagrams to standard deviation and a bell-shaped curve to now proportions or ratios. All right, so anyway, there are 80 people who attended classes at Vetrone's driving school. Okay, so there's 80s our total. The ratio of boys to girls is 2 to 3. A student will be randomly selected to compete in a driver safety contest. What's the probability that a girl is picked? So we have to find how many girls and boys there are. And so if the ratio is 2 to 3, then it's 2 times some number plus 3 times some number gives us our total. So if there were 10 girls, or if our scale multiple is 10, 2 times 10 is 20, 3 times 10 is 30, 20 plus 30 doesn't equal 50, so I know X is not 10. So what we're trying to find is our scale multiple that would get these ratios to add up to 80. So we say 2 times some number we don't know plus 3 times the same scale factor of some number we don't know equals 80. Combine like terms, and we get 5x equals 80. Divide both sides by 5, and we find x. 5 goes into 8 once, 5 goes into 36 times. So this is a scale up of 16. So if I take that 2 times 16 plus 3 times 16, that should equal 80. So 2 times 16 is 32. 3 times 16 is 48. And 32 plus 48 definitely does equal 80. Okay, so we just answered the question, and you have to be careful. It's boys to girls in that order. Okay, the colon is the word 2. So boys 2, girls 3, and then what's the probability that it's a girl is chosen? That's our 3, and that is this number right here. There are 48 girls, and the probability that it is a girl is going to equal the number of girls over our total. So that's 24. Let me just 24 over 40, 12 over 20, 6 over 10. 6 over 10, that's 60%. 48 over 80, or 60%. And that is equal because it comes out exact. All right, check your understanding. The ratio of seniors who are licensed drivers to seniors who are not. Okay, licensed, not licensed. Same order, licensed. Whoops, good Lord. Licensed, not licensed. Total. If there are 190 seniors, find the probability that a randomly selected senior will be a licensed driver. So we say 7x. Let me just do it with color. Hang on, another coughing fit here. Okay. 7x plus 3x equals 190. 7x plus 3x is 10x. Divide both sides by 10 and x is 19. So licensed is 7 times 19. Not licensed is 3 times 19. Okay, and I'm just going to show all this to check my answer. So 7 times 19, 7 times 20 is 140, minus 7 is 133, plus 3 times 19, 3 times 20 is 60, minus 3 is 57. And those have to equal 190. 7 and 3 is 10, carry the 1, 5 and 3 is 8, plus 1 is 9, and the 1, so that is 190 equals 190. All right, so now I can answer the question. Find the probability that a randomly selected senior will be a licensed driver. Licensed driver. The probability that they are licensed is going to be the number of licensed drivers divided by our total. 133 divided by 190. 0.7 or 70%. Okay, 7 out of 10 or 70%. Okay, that is the end of chapter 4.4. Thanks for watching. Have a great day and peace.